myself, Dr. Lakshmi Roy, to talk on time series analysis by least square method. So we have already done a number of classes on time series analysis. Today I will give importance on the importance of time series analysis in geographical studies and the method, especially least square method. Now, this time series analysis, that means what is time series? So, a series of observations recorded in accordance with the time of occurrence is called time series. So, all we know geography, it is a natural science, and whatever we see over the earth's surface belong to geography. So, all geographical data are time series data because the phenomena which we observe are daily changing. So these are very dynamic, not static. So that is why time series is very important in our geographical studies. Time series may be monthly, yearly, weekly, daily, hourly, biennials, decimal, etc. So let us take an example of say this type of occurrences, like you see rainfall, water discharge, rain gauge, then you see temperature, rainfall, humidity, industrial output, agricultural output, then population density, sex ratio, etc. So these we can consider for time series analysis to predict the pattern of changes and their variations spatially. Now using different method, it is possible to predict the changes with time. A major spatial application of time series analysis by geographers is in the last few decades is the prediction of the return periods of epidemics, then outbreaks of measles, influenza, AIDS, flood magnitude, etc. So studying the relationship between the variables, it is possible to produce predictive models. And time series data are used in also weather forecasting, then you see sunspot activity, earthquake prediction, etc. So the main objectives of time series analysis is to explore the pattern of changes in order to explain the variations and finally to fit a model for making predictions with reasonable confidence. Now, let us talk about the least square method. So this is least square method. So this is one of the most important technique of studying the time series analysis. So the principle of least square method is one of the best ways of obtaining the trend values. So the method is based on the mathematical calculations and which is used for both linear and non-linear trends. Now in our UG classes, we need this linear trend. So that is why we will apply this least square method for linear trend analysis. Now this method fits the line through a series of points in such a way so that the two fits the line through the series of points in such a way so that the sum of the deviations of actual points above and below the line is 0. That means you see that is summation of y minus yc equal to 0. Then another second one is the sum of the square of the deviations of the actual points and the computed values is minimum. That is y minus yc to the power square equal to that will be least. Now this for linear trend, you see the equation of the straight line is yc equal to a plus b t. Now these two conditions, that means summation of y minus yc is equal to 0 and another one summation of y minus yc whole square is the least. So these are the two conditions which are approved by this least square method. Now the straight line equation, we know the straight line equation is yc equal to a plus bt. Now where yc is the predicted trend value. So yc is for the predicted train values. And A, B, these are the constants. These are constants and T is the time here. It is time. Now, so this A and B, A is called the intercept. Y-intercept. A is called Y-intercept or the computed train figure of Y variable when t equal to 0. When t equal to 0. Now t is called the unit of time. Now to find out A and B. So to find out A and B, two normal equations are considered. So what are those two normal equations? Two normal equations are considered. Number one, it is y summation of y equal to na plus b into summation of t. So this is equation number 1. And number 2, summation of yt equal to a into summation of t plus b into summation of t square. So this is equation number 2. Now here the first equation that is equation number 1 is simply the summation of the given function. So this you see, these are simply the summation of the given functions. And second equation, so these equations, second equation is the summation of t multiplied by the given function. So here in this second equation you see, this equation is multiplied by t. So second equation is the summation of t multiplied by the given functions. And n. So n is called the number of years. N is called the number of years, or it may be months, etc. of the data given. Now, when t equal to 0, when t equal to 0, summation of t equal to 0, where middle year is taken as origin. When t equal to 0, the equation will be summation of y equal to na, since b into summation of t equal to 0. Then summation of yt equal to b into summation of t square, since a into summation of t square equal to 0. Here a is also now therefore a equal to summation of y by n, and b equal to summation of yt by summation of t square. Now here a is also called the mean of y values. A is also called the mean of y values, and b is called the rate of change. Now here again important conditions here. When number of pairs n is odd, we can take equal to time minus midpoint of time divided by interval in time. And number 2, when n is even, then t equal to 2 into time minus average of two middle points of time divided by interval in time. Now, so this is the theory behind this calculations of the least square method. Now, the steps to follow. What are the steps? Here, to calculate the least square method. Now you see the steps. Steps 1. Step 1. This consider t as the time variable. Consider t as the time variable. Second step is y as the train variable. Y is the train variable. Then third is middle year is considered to be as time of origin that is t. Then number 4, square the time deviations. Square the time deviations and sum up. That is summation of t square. Find out mean values of y. That is a equal to summation of y by n. Summation of y by n. Number 6. Multiply y values with t and sum up. That is summation of y into t. Number 7. Find out b. That is b equal to summation of yt by summation of t square. Next one. Substituting the values of a and b in the equation y is equal to a plus bt for various values of t, for various values of t. We can find out the predicted value of y for different years. So these are the different steps to follow for calculating the least square method. Now let us consider an example here to find out the predicted values as well as to fit the curve on the graphic. Example, calculate the trend values for by least square method, by least square from the data given below. So it is given here. Now production. Here suppose 2011. So here given, then production is by 12, 30. So now you have to find out T here. Find out T. Now before finding T, let us find whether n is odd or even. Now n here it is 1, 2, 3, 4, 5, 6, 7. So n here it is 7. N is 7. So it is odd. Now in this case 2014 is considered as the point of origin. So this is, now you see T will be year minus this 2014. Now take the deviations from this 2014, which is considered as the origin, point of origin. Now you see this 2000 year minus 2014, that means first one is 2011 minus 2014, so it is -3. Then 2012 minus 2014, it will be -2. So next one will be -1, next is 0, again it is 1, 2, 3. So this way we are getting T. Next one is T square. So it is 9410149. Now you sum up this T square. So it is 28. Next, y into t. So it is -36, -26, -13, 0, 19, 50, 69. So again you sum up this summation of yt is 63. Another one option here, you have to sum up these y values. So it will be 121, summation of y equal to 121. So that way you can calculate the trend values. So trend in estimated production yc equal to a plus bt. Yc equal to a plus bt. Now a equal to how much it is? We know a equal to we have to find out a equal to summation of y by n. So summation of y is how much? It is 121 by 7. So it is 17.28. And b it is summation of yt by summation of t square. So it is 63 by 28 equal to 2.2. Now placing this a and b in these equations, we get first one, it is yc equal to 17.28 plus 2.2 into minus 3, so that will give you 10.68. Then following the same method, so you see 8.6, next one is 10.8, that is 17.8, 18.8, 21.68, and next is 23.88. So these are the trend values, predicted trend values of these y values in different years. So now you can construct this trend line on the graph paper using this data. So that will give you the least square method in graphical form.